Good morning, distinguished colleagues. It's February 16, 2022 at 11 a.m. Moscow time. We're beginning the panel session for the defense of the thesis by Li Yin. The thesis is submitted for the academic degree of candidate of sciences in physics and mathematics. The specialization is 1, 2, 3. Theoretical informatics and cybernetics. The topic of the thesis is solutions of spanning tree games. Under the order issued by the Academic Secretary of St. Petersburg State University as of December 3, 2021, number 11657/1, I, Artyom Sedakov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Mathematical Game Theory and Statistical Decisions of St. Petersburg State University, was appointed the chairman of the board. The order also approved the members of the board, namely Elena Parilina, Doctor of Sciences in Physics and Mathematics, Professor, Department of Mathematical Game Theory and Statistical Decisions, St. Petersburg State University. Ekaterina Gromova, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Mathematical Game Theory and Statistical Decisions of St. Petersburg State University. Alexander Krylatov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Mathematical Game Theory of Economic Decisions of St. Petersburg State University. And Vladimir Mazalov, Doctor of Science in Physics and Mathematics, Professor, Head of the Institute of Applied Mathematical Research of Karelian Research Center of the Russian Academy of Sciences. And the following members of the board are working remotely today. Oleg Malafeev, Doctor of Science in Physics and Mathematics, Professor of the Department of Modeling in Social and Economic Systems of St. Petersburg State University. Oleg, do you see and hear us? Yes? Okay, the answer is yes. And Dr. Li Dengfang, Professor of the University of Electronic Science and Technology of China. Professor Li, do you hear and see us? Yes, everything is okay. And let me introduce you the candidate for the degree. That's Li Yin. And Leon Petrosyan, Doctor of Sciences in Physics and Mathematics, Professor, Dean of the Faculty of Applied Mathematics and Control Processes, Head of the Department of Mathematical Game Theory and Statistical Decisions of St. Petersburg State University, is the thesis supervisor. He is here with us. I would like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and our board session is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to Mr. Li Yin online, questions regarding the thesis or the scientific discussion or the content of presentation, and thus they can participate in the academic discussion. These questions will be forwarded to me by our technical service, and I will read them out during the discussion. Questions must be related to the presentation and the content of the thesis, and do not forget to give your name and position if you submit a question. The questions that have nothing to do with the scientific discussion or the text of the dissertation or to the general estimate will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local regulatory acts, the session of the dissertation board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. The dissertation board consists of 7 people. Everyone is here today, including 2 members of the board who are working remotely. And we have a multimedia connection with them, thus we have the quorum. Therefore, I kindly ask the member of the Department of Dissertation Board Support to fill out the attendance list. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Chairman's replies to questions, if any. Then the candidate's presentation providing an overview and findings of the research. 15 minutes will be given to that. Questions to the candidate regarding the presentation, no more than 2 minutes per question. The candidate's replies to the questions. Then reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions, or maybe some proposals, 10 minutes each. Then the chairman's report on the thesis, 10 minutes for that. Then the candidate's comments about the reports on the thesis and replies to the questions, 20 minutes for that. Then we're going to have an open discussion, speeches of those present at the defense with brief presentation of their positions or questions or suggestions to the candidate on the topic of the study. 10 minutes per speaker. And don't forget to state your full name, academic rank, position, and place of work in the registration list. And don't forget to introduce yourself before I give you the floor. Then the chairman will ask the questions submitted during the broadcast via our website. Then I would like to draw your attention to the fact that written questions that will take more than 10 minutes to read out will not be voiced. Then the candidates' replies to the questions, 10 minutes per question. Then the presentation of the candidate's thesis supervisor, 3 minutes for that, 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense is not broadcast, so we may have it or may not. Then open balloting, we are going to count the votes and record the results in the protocol. After that, we are going to make a decision on whether to confer the academic degree to the applicant or not. And finally, we are going to listen to the applicant's closing speech. Distinguished colleagues, any questions or objections on the topic? No, none. Okay, thank you. No objections. Let us start. Then, first of all, I would like to ask you to switch off the sound on your mobile phones. Thank you. So, let me start. So the chairman's presentation, the thesis by Li Yin for the academic degree of candidate of sciences in physics and mathematics, the specialization 1, 2, 3, theoretical informatics and cybernetics, is titled Solutions of Spanning Tree Games. The thesis is approved for the defense by the order of the academic secretary of St. Petersburg State University as of October 27, 2021, number 10-287/1. Li Yin has prepared his thesis at St. Petersburg State University as a postgraduate student, and I've already introduced his thesis supervisor, Leon Petrosyan. 4 published works describe the research findings. All these articles are published in journals indexed in Web of Science and Scopus. All these documents, as far as I'm informed, comply with the general requirements of St. Petersburg State University and are found in the certification file of the applicant, and the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies. And before I give the floor to the candidate for the degree, I would like to ask the members of the board, do you have any general questions to our applicant? Is there a need to consider the whole list of documents submitted by the candidate? No. No need for that. Okay, so please, Lee, have the floor. Mr. Lee, have the floor. Thank you so much. And distinguished members of the board, I would like to introduce my presentation on the thesis presentation titled Solutions of Spanning Tree Games. The thesis was prepared at St. Petersburg State University, and my academic supervisor is Professor Leon Petrosyan. This thesis contains different models of cooperative games with spanning tree, and it is dedicated to methods of construction of cooperative decisions for these models. Above all, the obtained results can be used in cooperative stochastic games with a spanning forest and multi-stage cooperative games with spanning tree with full information. And as for the order of the chapters of my thesis, I would like to introduce the content of each of the 3 chapters. First of all, I give the short description of the game models, important new definitions, and important results in every chapter. On this slide, you see the basic definitions that I used in my thesis. I would like to explain 3 important definitions before I introduce the general work on my thesis. First of all, let us define the cost matrix. Please have a look at slide number 6. That's an example. Yes, that's it. Yet another definition is vector, the strategies of players. Cost matrices of graphs obtained in this example are different for all the players with different strategy vectors. And on this slide number 9, I give the definition of a minimal or spanning tree. And in graph G, the cost matrix looks like Cx in the situation X. And now let us consider the first chapter, the dynamic Shapley vector in two-stage game with a spanning tree or spanning forest with shock. Let's consider the two-stage game with a spanning tree first of all. As you see on the image, after the first stage, player M can leave the game with a probability that depends on the previous behavior of other players. The game process is described in details on page number 30, the definition of strategies of behavior of players on the first and second stage. So you see them here. That's the probability of the fact that player M will leave the game at the second stage, and it depends on strategies of players on the first stage. Considering that all players jointly choose strategies to minimize the expected cost sum, we found the value of characteristic function for n set as a solution for problems of optimization with cooperative strategies. And in this thesis, I defined the characteristic function in accordance with the method offered by Charles Bird in 1976. He defined the characteristic function for coalition S as Vs as a minimal sum of costs for the login of all the S players to the source without players from n/s. And in a game of 4 players shown on the image, the coalitions S and NS are found in yellow and in green areas. And when we consider the characteristic function for coalition S, the players in coalition N and S in the green area are not connected with players in S and 0. And similarly, we define the characteristic function in the subgame. Please have a look at page number 34. And based on the above-mentioned proof, in accordance with the mode of Carr of 2002, we define the Shapley vector in the game with spanning tree. And here you see the definition of imputation distribution procedure that I derived from the study of Leon Petrosian of 1979. Using the imputation distribution procedure, we can construct the dynamic Shapley vector. However, the constructed Shapley vector is not dynamically stable. And as for the details, you can see them on page number 36. And in order to resolve this problem, I formulated and gave the proof for the following theorem. This is the first result for the two-stage game with a spanning tree. When p equals 0, the set of players at the first stage is the same as at the second stage. In this case, the theory gives us a condition in which the resulting Shapley vector can take non-negative values. And it's clear that in this case, the Shapley vector in the game is dynamically stable. The second theorem considers the cost function, considering some specific conditions in which the probability of the fact that player M will leave the game equals 0. The cost matrix in this result depends on several conditions that should be met in order for this to happen. This is a particular type of network structure of the spanning tree when solution of this dynamic cooperative game is also dynamically stable. A more general condition is described in Chapter 3, in Theorem 3. The probability of player M to leave the game at this moment can be any. If we meet the conditions of theorem for the dynamic Shapley vector, we see Shapley vector constructed in accordance with imputation distribution procedure. It is dynamically stable in the two-stage game with a spanning tree. Then the second game model, as shown on the diagram. First of all, we define the cooperative behavior of the players. When we choose strategies, the players construct minimal spanning tree at every stage. Unlike in the model described in the previous game model, overall costs in the game consist of costs defined by the spanning tree and losses due to the use of perishable products. And similarity with the previous model is that at the second stage, player M leaves the game with a probability that depends on the previous behavior of the players. The goods, the quality of or costs of which drops in time are called perishables. For example, fruits, vegetables, flowers, and seafood. And below you see the definition of loss in value. This definition of spanning tree with perishables. The probability P of the fact that player M will leave the game is defined as in the previous model, and we can find this definition on page number 54. And here you see the game player strategies and characteristic functions in game and in the sub-game. Then we constructed the Shapley vector. The dynamic Shapley vector is based on the imputation distribution procedure. And we checked that the constructed Shapley vectors do not meet the characteristic of dynamic stability. And the descriptions and examples are given on page number 59. That's the third game model for two-stage game with spanning tree. And let us consider the particular cases. A game with a spanning forest. In this two-stage game, we consider spanning forest at every step. For models with several sources, different players can have different needs in sources. In other words, the set of sources needed by every player is a subset of general set of sources. The set of sources of the players the sets of sources of the players can overlap for different players. And below you see some of the definitions regarding this game model. And this over here is the definition of the minimal cost spanning forest. This is the definition of probability, or that player M leaves the game. And on this figure, all the green vertices are sources, and red vertice is player M, and other vertices are other players. Thus, we obtain the spanning forest, as you see on this figure. The probability that player M will leave the game actually depends on the overall costs for the path of this player to all sources that we need to connect. And the higher these aggregate sums on edges or for the spanning forest, the higher the probability that the player M will leave the game. And like the previous game model, I provide the strategies of behavior and characteristic functions for calculations in the game. I've constructed the dynamic Shapley Vector for this game model, and the peculiarities can be found on page 17. And that's theorem 141, and in this theory I demonstrate and prove that the dynamic Shapley vector is dynamically stable if it meets conditions 7. Then I consider a different chapter. In this model, after the choice of strategy at every step by players, the game shifts to other M vertices and with probabilities that depend on the strategies of players chosen at the first stage. So that's the probability scheme. The costs in every vertex are calculated as Adamar product between the cost matrix and for this problem we obtained theorems 211 and 212. And this is the definition of Shapley vector based on procedure of imputation distribution procedure, and you can find additional information on page 84. And for this problem of theorem 211 and 212, you can get this information in theorems in the previous chapter. Then in this chapter I considered a model that uses dynamic burgeoning Nash scheme. And I studied the dynamic Nash burgeoning solution. And I've proven theorem 221. That's chapter 3. In this multi-stage game, I considered cooperative option of the game, and I introduced the characteristic function, and that's the work from Pankratov and Petrosyan in 2018. And it demonstrates that C-core is strongly dynamically stable. And over here you see some other definitions, and please consider page 107 for additional information. And that's the definition of the new characteristic function in a game, and you can find additional details on page 110. And these are examples for the new characteristic function. And these are the definitions of the characteristic function in the game. And you can find additional information on pages 112, 113. And that's the definition of distribution, and of the set of distributions can be found here. And we obtained the following theorems. Thank you so much. And some comments were taken into account in my report, some comments of the members of the board. Thank you. I have one question to the members of the board. Do you have any general questions on this presentation that the applicant has just made? No. Okay. Yet another remark from our support service. Anton Alexeyevich, can you please, yes, point your new camera. Thank you. Okay. Now I'm going to give the floor to the members of the board for them to voice their criticisms and proposals to the candidate for the degree. I would like to remind you that you that you can answer all questions at once, or maybe you can answer questions after every review. So let's do it this way, after every review. As all the reports were already published on the St. Petersburg State University website and everyone had a chance to read them out, I offer to give just the basic points or maybe criticisms or questions that you had in your reviews. Any objections about that? No, none. Okay, now let's start. Professor Parilana. Yes, thank you very much for the report. First of all, I would like to say that overall I support this work and I have a very positive impression of this work. We've known Lenin for a long time and he demonstrated his results at many international conferences and Russian conferences, and he started here as a student. So we observed his work for all these years and we support his work. You all heard the results of all his years of research. Certainly we have scientific novelty, and to my mind the applied part can be strengthened a bit, especially in the field of logistics. I believe you'll get some advice from other members of the board about the use of these results, about this application of results. And overall, I believe that this is more over theoretical research, and it complies with specialization 1, 2, 3, theoretical informatics and cybernetics. Overall, my comments, I'll read them out. They are mostly technical. They're not to the content, but to the presentation of results, you see. And I'll read them out. So I will read each question and then you can answer. The first remark is to the title of the work. I believe it's a bit generalized and all the results refer to cooperative games theory. Therefore, maybe you could call it the cooperative decisions of games with spanning tree. But that's a general comment. There's no need to answer that. The second point, in no chapter you provide the formal definition of the game, you provide the description of separate elements in different paragraphs, and it would be nice to have mathematical exact description of a game with the definition of set of strategies with functions of cost. And for example, on page 23 you provide the definition of player strategy, but you don't describe what is the set of strategies. And in definition 119 you said the function of cost, but from 1-2 it's not obvious whether this function is non-negative, this FC function. That's it. You can answer. Yes. Yes, as for the first question, yes, so I agree with you. And that's a good idea about a different title for this work. The second answer, yes, I agree with this remark. I will think and offer a formal definition of game with spanning tree in my future research. And this situation emerges as a result of strong differences between different game models with spanning tree in this thesis. The set of strategies of XIG are represented in definition 119 as all possible actions that player I can choose in a game with player J when defining costs on the edge IG. And next question, function FC is defined in section 119 as a reflection, as a mapping on the variety of positive values, so it's positive. Thank you so much. The third question, you don't have a very good definition of path from 0 to M. Why didn't you write POM? Yes, I agree with that. I could do it this way as well. The fourth question. This definition 1 to 11 has excessive conditions, and if you take into account the definition of 1 to 10 of imputation distribution procedure, we could omit it, but we would demand just non-negative component of imputation distribution procedure. And after this definition 1 to 11, you write it here. Unfortunately, in two-stage game with a spanning tree, IDP beta can take negative values. If we talk about costs, additional values demonstrate advantage, and this seems profitable to the player. Yes, I agree with that. The fifth question. In section 1.3, you consider the game with perishables, and you sum up costs of two types. If the second part of costs has some economic value, the first part would be nice to interpret and to substantiate somehow. Yes, I agree. I'll try to do that. Okay, thank you. Then question 6. In definition 136, you set the probability P of the player leaving the game 1. In the numerator, you take into account just one type of cost, and in the denominator, the sum of costs of the first and second type. In the thesis, I considered this particular case, and we can consider other options, and I'll plan to do that in the future. Thank you. Okay. Then on page 76, fifth line from above, you write, let's choose matrix CX, and then this matrix is defined as a choice of strategies by players. Yes, I agree. I should have written about it at once. Okay. So it seems to me that the fourth provision brought for the defense is technical. That's alpha matrix. It describes certain operation conducted on the network, and it has no significant importance compared to other provisions brought for the defense. Why did you introduce this provision in this list? Yes, I agree, first of all, that this item is more of a technical character, but as previously this approach was not used before, I thought that it is possible to include it in the list of provisions brought for the defense. Okay, I got it. Thank you. And misprints, I won't read it out. Yes, thank you. That's it, what I wanted to say. I'm satisfied with the answers, and I support this work, and I have a positive impression of this work, and yes, I'm going to read this words. The thesis by Lein deserves the academic degree of candidate of sciences in physics and mathematics in proper specialization. Thank you, Elena. Then I'm going to give the floor to Professor Gromova. Hello. Well, my review was already published as other reviews, therefore I won't dwell upon the content of this work in details. Therefore, I would like to just mention that the work supports the developments of the school of Professor Petrosyan, and it is dedicated to adaptation of obtained results by Professor Petrosyan and his other students in dynamics, strong dynamic stability, for some specialized structure of games. And the scientific novelty here is that obtained results consider this new structure in the construction of the function in imputation distribution procedure for Shapley Vector, and the Nash bargaining solution is described. So the thesis is written well to my mind. It's nice to see all these figures that are of high quality, to see all these results, but still I have certain comments on this work. I will read them all, and you can answer them all at once. May I do that? Yes. Certainly. The first. Problem setting is not formal enough. For example, in Chapter 1, definition 112, page 21, this arch of the graph ij cannot belong to the subset of the set of vertices n. Then the definition 114, this curve cannot belong to graph G. And this incorrect definition is something that you see on all pages. Then, in definitions, you don't consider that you work with fully connected graphs. Then, the statement that cost matrix defines the graph contradicts this fact that this matrix is defined by the graph. That's on page 23. That depends on the absence or presence of curves in between the vertices. Then, in definitions 1.1.13, 1.1.15, you use definitions that contradict each other, what Yelena has already mentioned. That Pj0 describes the path from vertex 0 to vertex j, and in the previous definition, PMO defines the path from m to 0. Then, the second comment. The list of literature has 71 sources, and mostly these sources are dealing with stochastic multi-stage games and network games. Though the concept that you implemented for spanning tree games, you studied in close wordings in the works of Kozutin, Kostyunin, Shevkoplyas, Petrosyan, Avanesov, Gromova, Mazalov, and others. The third criticism. Chapters 1 and 2 contain results that are dealing with two-stage games, and the author doesn't say whether it's possible to summarize the models and methods for multi-stage game. Then fourth criticism. Chapter 3 is dedicated to the problem of strong dynamic stability of C core for multi-stage games with spanning tree and full information, and it would be more logical to provide summarization of this problem to the class of multi-stage games with spanning tree with elements of stochastics. And unlike in the previous chapters, the results of this chapter are not illustrated on examples. And there are some stylistics failures. For example, the author uses simultaneously the source and different words for source, for connected, for costs on edges in Russian. But overall, this does not compromise, these remarks do not compromise the overall high value of this work, and I support this work. Thank you, Ekaterina. Mr. Lee, you can answer. Thank you so much. So my answers are as follows. For the first question, is that I agree with you here. I should have used this wording that any edge, ij, belongs to a subset of n multiplied by n. And as for the second remark, I agree with it as well. In definition 1.1.2, E is a set of all edges in graph G. However, some authors associate this graph with a set of directed edges. For the third question, I have the following answer. In the work, I consider just fully connected graphs. And this can be seen in particular from the fact that the costs are defined for all pairs of vertices. As for the fourth remark, I agree with that. I meant that cost matrix is defined by strategies of players. Thus, we define couple GC. And for the last question, yes, unfortunately, this was a misprint. I should have written it differently. The second question. These results of work are not used directly by me, but I understand that they are they have some relevance to the work. Therefore, in my further articles, I'm going to make references to these authors that you've mentioned. And third question. Thank you very much for this remark. I offer to summarize these results. Then, question 4. I agree, and I, by the way, prepare such work for publication. And the last question. I agree with this criticism as well. Yes, thank you. Next review. Professor Krylatov, please. Yes. Hello, thank you so much for the report. It's really fascinating. And I won't go into details like my colleagues, and I'll say that I have a very positive impression of this on this work. It was very nice to read it from the mathematical point of view. For example, these theorems are very exactly described. You have no misunderstanding here. The author continuously proves all the provisions, and that is really an advantage for these theorems. Theorems, the proofs for which requires more than one page. So this creates very good impression on this work. And colleagues have already mentioned that the applied part is a bit weak, but it seemed to me that the goal of this work is to demonstrate some managerial solutions, managerial decisions of impact on the systems considered. And to my mind, it's quite enough. And it's quite interesting to apply those results and analytical ideas that are provided in this thesis on some other examples. It's clear that these are all models that are considered in this thesis, but still the extrapolation can be done. And as for the criticisms, I have just few, and they are more of a conceptual character. First, it seemed to me that instead of two-stage game, you should have considered the model of multi-stage game in Chapter 1, and the question is, in Chapter 1, is there an opportunity to leave the game for several players simultaneously? So that's just interesting to solicit your answer here. And the third remark on pages 60, 61, 62. In calculation results, you have some heterogeneity in the number of decimal points. They would look nice if they were more homogeneous. And overall, I can say that I support this thesis. It meets the requirements at St. Petersburg State University to works in specialization, theoretical informatics and cybernetics. That's it. Thank you. Thank you. Mr. Lee, you can answer. Yes, my answers are as follows. For the first question, yes, I agree with this criticism. The construction of a multi-stage game model in chapters 1 and 2 are in my future plans. Then for question 2, that's a very fascinating topic, and overall I can say that the consideration of several players that will live the game simultaneously, or maybe random living the game, or fixed continuous Leaving the game leads to 3 different game models with spanning tree, and that's really of interest, and I plan to study that in the future. And as for the last remark, yes, I agree with it as well, and it does not influence my answer. Yes, thank you. Thank you. Alexander, are you satisfied with the answers? Yes. So, Professor Malafeev, you are next. Professor Malafeev, do you hear us? Your microphone is turned off, I believe. Yes. Yes, please. Your view. Yes, I won't add up comments to the previous colleagues. I just wanted to mention that there are certain misprints in the work that do not really influence the high quality of work, and this work is a finished study, and it has both practical and theoretical value. As for practical value, it can be used for perishables, and the results are published in journals indexed in Web of Science and Scopus, and the work itself complies with all the requirements described in the order on the procedure of granting academic degrees at St. Petersburg State University, and I believe the candidate for the degree, Mr. Lee, deserves the academic degree of Candidate of Sciences in Physics and Mathematics and specialization in Theoretical Informatics and Cybernetics. And Articles 9 and 11 of the above-mentioned order are not violated. That's it. Thank you. Oleg, thank you so much. No criticisms, okay? Yes, so the criticisms were insignificant. So, next, Professor Mazalov. A distinguished chairman, distinguished members of the board, distinguished applicant for the degree. So we consider this dissertation. And there are 2 points that I wanted to mention. First of all, that's a novel work, and no one doubts that someone had previously used dynamic stability for the games of such type. And the second point that I liked is that this work has a lot of possibilities to continue. And I really like such works when you read a work and all of a sudden you have all these ideas how to continue this work. And here we have a lot of future possibilities for study, and I believe it's a great possibility for the applicant for the degree to consider these issues later on. But I have some criticisms. I'll read them out, and then you can answer. First remark: models with one source, chapters 1, 2, 1, 3. In such models, characteristic function is defined as a minimum of costs in all connected graphs, and it leads to the construction of spanning tree. The models with several sources, section 1.4, the cost minimum is taken at all possible graphs, and this has an opportunity not to give us the spanning forest. Second, in this work, you use 2 types of graph: graph G, where the players are vertices, and the game trees, Z1, Z2, and so on. So this can give us a kind of mess. So you should have mentioned it in the text at once, that initially called vertices as vertices, then as positions, and so on in the Russian language. So you should have taken this word vertex at once. I believe you should have avoided this mess somehow. Then, in the game, the player A participates, and you don't describe his share in the procedure. Then, strategy XIG is called as action of player I against player J. Why so? Because we are talking about cooperation, but you corrected it in your report, and in then you add up 0, source 0 to S dash. Why do you do that? And then theorems 1, 2, 1, 1 to 2 are described as follows. At In a two-stage game, we have a player that can leave the game at second stage with the probability of leaving depending on the choice of other players at the first stage. Is it a statement or a condition? Because, for example, we can have a game that will repeat 2 times, and in this case, imputation distribution procedure is not needed. But overall, I believe that this thesis meets the requirements of the orders of November 19th, 2021 on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Lean deserves the academic degree of Candidate of Sciences in Physics and Mathematics and Specialization 1, 2, 3, Theoretical Informatics and Cybernetics. Thank you. Professor Mazalov. So, Mr. Lee? Yes, my answers are as follows. For question 1, cost minimum is taken not in all possible graphs, but also in graphs where player I is connected with a set Mi. So these are sources. It's terms from definition 142. As for criticism 2, I agree with this comment. As for the third question, imputation distribution procedure of player M is not described particularly for every model of the game, because the calculation of imputation distribution procedure are already provided for every player, including player M. And then, question 4, I agree with this remark. Instead of against, you can use with the player. And then the fifth remark, as 0 is the source, then it's a vertex as well. The vertex that all players want to log up to, but this vertex is not a player and it does not participate in the game process. This definition demonstrates that there is a network that has this collision S that is connected with source 0. And as for the last criticism, I also agree with it. That's a condition, and P can also equal 0. And in this case, the game of set of players does not change, and we have no problem here. However, in this case, I drew certain conditions when Shapley Vector is not negative for theorem 121. Thank you. Thank you. Are you satisfied with the answers? Yes, I am. Okay, next review, Professor Lee Denfen. Professor Lee.
Me? Okay. I have given a detailed comment about this dissertation. In here, to several times, I will give a brief remarks. Lee's dissertation main studied the dynamic stability of different complexity solutions in dynamic complexity games with spanning trees. He proposed several game models of various types, including stochastic and non-stochastic, two-stage and multi-stage, as well as simple and complex network topologies. I think this model, game model, has a theoretical finance and scientific narratives. Specifically, he gave 4 important models. One is that in this dissertation, Lee proposed a two-stage spanning through two games with blockers and construct the solution. the tool is in this dissertation, Lee consider the model with several sources in the network. This is a two-stage spanning Forest game with a socket. Then Lee define a new alpha matrix for modifying the network in the one-stage spanning tree. Again, he used the new alpha matrix to define and study a multi-stage spanning tree game with community information. I think all the game model and the solution can be used to many economy and manage situation. So the work is interesting. I think this dissertation completes the scientific research at a high level and is of theoretical and political interest. So I think Lee deserves to be granted with a degree. I have two questions. One is in the section 1.2, 1.3 and 4, is it possible to consider the case of multi-stage game with spanning tree? Now the question is, can use other approach to define the trajectoristic function? This is my two questions. Thank you.
Спасибо, профессор Ли. Пожалуйста.
Thank you, Professor Lee.
I'm currently working on the case of the game models in chapter 1 and 2, which are multi-stage games. For second question, yes, I agree with the comment. It is possible, and I will try to do this in the future. Thank you.
Professor Ли, вы удовлетворены?
Professor Lee, are you satisfied with the answers?
Yeah, okay.
Спасибо.
We have yet another point. As we have our session in the Russian language, could you please answer in Russian as well? Yes, as I've already said in English, I agree with these comments, and now I'm currently working on the case of the game models in chapters 1 and 2, which are multi-stage games. And as for the second remark, I also agree with the second comment, and it is possible to do that, and I will try to do this in the future. Thank you. Thank you. Okay, then my review. Overall, I wanted to say that this work has a good practical potential if we talk about transport and logistics systems, and very interesting models may emerge when we distribute the costs, when we distribute the costs and consider perishable products, and also the spanning forest was an interesting model. So do you believe that one source can, for example, fail, but at the same time what? An interesting model may emerge when the point of delivery at some point stops taking goods, and participants need to adapt the network, supply network somehow. And in this case, the potential is pretty good. And I won't dwell upon the technical points. There are certain inaccuracies in definitions or in different wordings, and it was already mentioned by colleagues. What I would like to dwell upon is as follows. On page 17, you say that in articles 63 and 64, the cooperative decisions in games with spanning tree are summarized and transformed as applied to different problems, but you do not discuss how you summarize these solutions. A second point, in chapter 1, quite frequently you repeat this concept of dynamic Shapley Vector. But in fact, the definitions are not given. You operate this term, Shapley Vector, and this dynamic Shapley Vector is the definition that you do not give. And the fourth remark in my list is that is dealing with the probability of a player leaving the game. And on the one hand, it depends on the actions that players choose. And on the other hand, in the text, it is defined just by P. And it's not always a successful choice, because in the definition of characteristic function, when you write the minimum, it seems that P is just taken out of this minimum as a constant. The fifth point. You provide non-standard definitions of the procedure of the distribution of Shapley Vector, and invitation distribution procedure is a kind of redistribution in time. And in your definition, in all your definitions actually, these procedures are offered specifically at once, and we just restrict ourselves somehow with payments. And in definition 1 to 10, the payment method 2 at the second stage is independent of the fact whether the player M left the game or not. I believe this payment should be adapted to this situation. Then, what else would I like to draw your attention to? This last remark. In definitions 21719 and setting the function of V1 and V2, you do not explain why the players beyond coalition S should minimize overall costs of coalition S. For example, if V from S demonstrates the minimal costs of coalition S, then why you take minimum there in strategies for all the players? I believe that's it as for the remarks, and overall I would like to say that the thesis by Lean meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Lean deserves the academic degree of candidate of sciences in physics and mathematics in specialization 1, 2, 3, theoretical information and informatics and cybernetics. Thank you so much. Thank you so much for the remarks. As for the first remark, and for the second, fourth, fifth, and 9, yes, I got it. My answers are as follows. For question 1, I agree with this criticism. For question 2, my answer is as follows. Yes, I agree. And the answers to these questions can be found in the works of other authors. Therefore, just to save some time, I didn't give them, though maybe I should have done it. The fourth question, I agree with it. Then the fifth question. Squared beta actually depends on M. Please consider page 36, because that's the average value. On the second stage. And the last answer, I agree with that. I didn't use the correct definition. I should have written x taken to the degree of -1 as z1. And in example 212, I've did it, so that's a misprint. This was a misprint. Thank you. Thank you. I would like to ask the members of the board once again if Everyone is satisfied with the answers. Yes, we are. Yes, okay. Now, anyone present here at the defense that are not members of the board, do you want to comment something? Okay. Then, questions submitted during our broadcast from external listeners. Did we get any such questions? None. Okay. Then, Professor Petrosyan, could you tell us about the applicant for the degree? The speech of the supervisor. Thank you so much. You discussed this issue in details already, and I would like to emphasize certain points. This cost matrix is constructed based on player strategy. The players choose certain strategies, construct this cost matrix, and based on it, we construct the minimal cost spending tree. So that's a real process, and after that we study cooperative behavior. That gives rise to a minimal spending tree. So this cooperative behavior at the level is acting at the level of creating of this matrix. It's not well presented, but still we had this idea here. And there is a novel idea here as well on these perishable products. So this dynamics process was not previously considered, and opponents have already mentioned that. Mr. Lee has demonstrated quite a creative approach, and in the work we have a lot of creative elements, and I hope that he will continue developing this work. Certainly I support this work, and that's it. Okay, thank you, Professor Petrosyan. Anyone else willing to say something? Okay, here we stop the discussion and we stop taking questions. And before we draw conclusions and vote, I would like to ask the members of the board and the candidate for the degree, are there any comments or questions on the procedure, on our procedure of defense, maybe those associated with remote access? No? No questions? No? No questions? No? Alexei, any questions? No? No? Okay, Professor Lee, do you have any questions?
No.
No. Okay, thank you. Now, next item in our agenda, the vote. My colleagues, dear colleagues, we have an opportunity to announce a technical break to discuss the results secretly, and these results will not be broadcast. Do you think we need such a closed discussion? No need for that. Okay. Oh, no, we do need. Okay, then we stop our broadcast to discuss the results. Ekaterina said she wants to discuss everything in a closed manner. So now it's 12 minutes past 12 noon. Dear colleagues, we continue our session. I would like to ask you to turn on the broadcast. And let's check whether we all hear and see each other, dear colleagues. Oleg, do you see and hear us? Yes, I do. Professor Lee, do you see and hear us?
Yes.
Okay. Then I raise a question on the award of the academic degree of candidate of sciences in physics and mathematics in specialization 1 to 3 theoretical informatics and cybernetics to Mr. Li Yin. I would like to emphasize that voting for the award of the academic degree, each member of the board agrees that Article 11 of the order is not violated by the candidate. I would like to quote it. In the thesis, the applicant for the academic degree is obliged to cite the author and or the source of the materials or individual results borrowed using the results obtained by the applicant personally or in co-authorship. The applicant for the degree is obliged to note that circumstance in the thesis. Let me remind you also that the decision on the board on conferring the academic degree is positive, provided more than 50% of the board members and not fewer than 3 people voted in favor, in conformity with Section 17 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. So, Professor Parilina, what's your opinion? I support this work. Professor Gromova. Yes, I also vote for the award of the academic degree. Professor Krylatov. Yes, I support this work as well. Okay. Professor Malafeyev. I also support this work. Professor Mazalov. I support this work as well. Professor Lidenfan, what's your opinion?
Support.
Спасибо.
Thank you so much. And I, chair of the board, Professor Sidakov, also support this work. Now, let us count the votes. So it's quite simple. Thus, dear colleagues, I would like to announce that out of the 7 members of the board, 7 voted for the award of the academic degree, no one voted against it, and no one abstained from the vote. Thus, the decision on the award of the academic degree to Li Yin in theoretical informatics and cybernetics is made. So the finalizing words of the applicant. So, Mr. Li Yin, you have the floor. I'm really happy. First of all, I would like to thank all the members of the board. I would like to thank you for the careful reading of my thesis. And I thank you for your numerous and highly valuable remarks. And I am going to carefully think all your comments, and I'm going to improve my studies in the future. And I would also like to thank my thesis supervisor, Professor Petrosyan, who for all these years supported me and helped me in my studies. His long and patient guidance of my study rendered a great help to me in writing this thesis. And I would also like to thank St. Petersburg State University and the Ministry of Education of Russia, because they provided me a valuable opportunity to arrive here and to study here. And I would also like to thank all the professors of our faculty who helped me. I would like to thank the Department of Dissertation Board Support, the curator of the defense, and the interpreter as well for their help. And I would like to thank my friends who supported me so much. And finally, I would like to thank my parents and my fiancé, who supported me so much in life. Thank you all. Thank you, Lee. So here we stop our session. I declare an end to our session. I would like to thank everyone for participation, and please turn off the broadcast.